All right, welcome back. In this installment, we're going to be installing all the electronics and doing the wiring for the Blue Eagle Labs all-metal Delta. In this step, you're going to need the completed all-metal Delta frame assembly, your maker base board, the M3x14 board screws, and the plastic standoffs. The maker base board goes on the bottom tray right about here. There are pre-drilled and pre-threaded holes in the base tray that will align with the holes in your board. Just make sure you have the orientation correct. These two black jacks are for the LCD panel, so they should face towards this bracket that holds the control panel, and the Ethernet and USB jack should face towards the center. It'd be easier if you stand the spacers like so. I'd keep all the screws loose until all four are started. That gives you a little room to maneuver and position the spacer underneath the board. Don't over tighten the screws and damage the PC board. All right, next we're going to mount the LCD to the metal control panel. It goes like so. Similar to as before with the standoffs, but this will have a nut in between the LCD screen and the red control board. So it goes screw, spacer. Oh, make sure you do it on the right side. Screw, spacer. Board. And this may be tricky. We need to get a little nut in between there. So for this step, you may additionally need needle nose pliers in addition to your Allen key. After all four are threaded, you can tighten them up snugly. Don't over tighten it again and damage the PCB. There. While we're at it, we can plug in the two cables. And our LCD is ready to install. All right, now that we've completed the control panel, it's time to mount it onto the tray. For that, you're going to need the M3x14 faceplate screws and some of the M3 nuts. I find it easiest to start all of the screws on the faceplate like so. What happens is that they lock into this little groove on the tray, and that holds the faceplate locked down and forces it onto these little tabs that go into the square holes. It's a bit tough to line individually, So if we do it like this and keep them loose, we can slide it on and then tighten it up when everything's in place. Like so. Keep the cables out of the way, and like so. And you can, it should want to snap into place somewhat when everything's aligned, and you can tighten up the screws. I'd move around and tighten them all up gradually, and then go back around for a final tightening when everything's snug. And like so. Lastly, we can connect the cables to the control board, and they do not cross over. They're labeled EXP1 and 2, so if you have any doubts, you can double check them, but they go like that. And our control panel's assembled. All right, now we're going to mount the SSR and the 12-volt DC power supply onto the tray. For this, we're going to need the M3x14 SSR screws, some M3 nuts, and some M3 washers. The SSR is going to mount onto the tray like so. There's a slotted hole and a regular hole. That just allows for some different models and variances. The machine looks a little off kilter because I have it tipped up for better viewing purposes for the video. Don't be alarmed. The SSR mounting holes aren't threaded, so you're going to need to put a washer and a nut on the underside of the tray. Like so. Next, we're going to mount the power supply. That's going to go over here, and we can use the holes in the tray to mount it using zip ties. The AC cable is, I'm going to have oriented towards the inside because that's going to be cut and split to go through the relay and the hotbed heater. So I'll leave this cable on the outside. We're going to cut this also and run it to the power jack on the edge of the board here. So figure out about how much cable you need, add a few inches just to be safe. And you can cut that right now and strip the end. So this is the DC side that's permanently attached. The cables inside are red and black. On the AC end, the one where the cables are removable, when we cut that, the cables will be white and black. So like so. And I'm going to kind of put some zip ties together. Like so. There. Next, you can solder these wires, and we're going to mount them into this screw terminal jack right here. If you want to solder that to make the wire stronger, I recommend it, but you don't need to. Make sure you have the polarity of the wires correct. Red is positive, black is negative. And you will probably have to unscrew the terminal screws all the way out first. They usually come tightened up all the way. Actually, before we insert that, I'm going to find the extruder fan wire that's bundled up with these cables. This one's going to be mounted into this jack also, because it is always going to be on when the printer is powered up. If you're thinking ahead, it may be smart to label this before you get everything bundled. So I'm just splicing in an extra wire that's going to power the extruder fan, which will always be on. And inserting the red into the positive side, tightening it down, and black into negative. Do a really thorough visual inspection. Make sure there's no loose wires crossing over here, because if you have a short, at this point in particular, it's trouble. So something like that. This is the X column motor, the Y column motor, the Z column motor, the extruder 1 motor, extruder 2 motor. These are your end stop switches. This is the X top end stop, the Y top end stop, and the Z top end stop. This is for the Z probe. This is the hot end thermistor. This is the hot bed thermistor. This is the triggerable fans. This is the hot end heating element. And this is the signal for the solid state relay for the hotbed, to power the hotbed. And then this is input, the power, 12 volt. And also tied in with that is the power for this hot end fan that's always turned on. All right, we're about ready to start plugging everything into the control board. One thing, in the last construction video, I assembled the end stop switches and wired everything up then. If you haven't done that already, go and do that now. And the end stop switch cables can be routed down through the back channel like this and up through the little slot in the center, and that keeps everything kind of nice and tidy so you don't have loose wires dangling around. But let's start with the motors. The motors go in these white sockets on the edge of the board, starting with the X-axis, which when you're facing the front screen of the machine, the X will be on your left, the Y will be on your right, and Z is the one in the back. So this is the Z axis. I'll start with this. Untangle the cable. Like so. I think the default orientation, it was with the blue cable towards your left if you're looking at it right side up. If the motor is going the wrong direction, or you need to reverse the direction of the motor for any reason, all you need to do is switch the orientation of the wire. But make sure you do this when the machine is turned off and the motors are not running. As always, if you'd like to see diagrams of the wiring, check out the Blue Eagle Labs website and wiki pages. I'd also recommend making somewhat of an effort to keep the cable management under wraps now. As you start plugging stuff in, this can turn into quite a beast, and it's going to be much easier to kind of like keep things organized and visually separate for debugging and any kind of troubleshooting you may need to do if it's not just a giant rat's nest of cables shoved in under the build plate. All these extra holes here are for mounting cables to the build tray. So I'm going to kind of just tether things in place temporarily, and then when I know where everything needs to go, I'll go and wire it down a bit more permanently into those little anchor holes. So there are the motors. I'm going to fish through the remaining 2 end stop switches. When you're routing wires, just be careful that nothing gets cut on any of the edges or broken. The metal can be a little sharp, and if you drag the wire along the edge, it could kind of shear off the insulation and actually be shorting out onto the metal frame. Okay, so the end stops are going to go into this row of 3-pin sockets to the right of the board when you're looking at it right side up. And remember, the left side when you're facing it is X, so this is the X end stop. And if you look at the board, there's actually 2 sets of X end stop switch jacks, X plus and X negative. We're going to be using the X plus because it's at the top and it's rising. And we're going to use the 2. Our wires are only 2-pin and they're 3 pins in the socket, but we're just going to use the S and the G side. So this is going to be X plus, and with the end stops, it doesn't matter which way they're oriented in terms of like polarity because they're just continuity switches. So I'm going to thread this under here. Keeping track of the wires and how they're managed at this stage will behoove you down the road. So this is Y, this will be Y plus. The top of this is going to be Z plus, and the bottom bed probe is going to be Z minus. So we don't have that installed yet, so I'm going to just skip that. Like so. So now we have the end stops all wired. Okay, next we have all the cables coming off the effector plate, with the exception of the hot end fan, which is always on and is tied into the main power supply. So that one's taken care of. So next I'm going to wire up the effector plate fans. These are used to cool down the filament, and you control that with the build specifications. It's different than the hot end fan, which is always on and, like I said, is tied in, which we've already wired into our power supply. I'm going to use a short little pigtail for this, so if I ever need to remove the effector plate, I can simply unplug this, and it makes it a little easier. You can wire it directly. But the fan goes into this leftmost block on the green terminals right here. And note the polarity, it does matter. I'm going to use a pigtail for this so I can disconnect the effector plate down the road and swap it out with something else if I need to. You can wire it directly. But the fan goes into the leftmost green terminal block. That is labeled fan. And it also has a plus and minus symbol. Remember, red is plus, black is negative. So keep that in mind. And then I'm just tightening it up like so. There's no real predetermined method of or orientation for how you want your cables to come out of the effector plate. Typically what I've seen is like a zip tie or rubber band kind of elastic hanging thing that allows the cables to be tethered out of the way of the build action, but also move freely and have enough slack so it's not yanking out of the control board. So right now would be a good time to kind of come up with a solution that works for you, and maybe mount these guys up here. You can see on our older Castle Clear the way we have the cable routing. You might need to come up with a slightly different solution, as the all-metal Delta doesn't have the crossbars at the top, but I'm sure you can figure something out that works. Next, I'm going to wire in the hot end heater into the leftmost green terminal jack that's labeled heater 1. These do not have a polarity, though the terminal is labeled positive and negatives, but it doesn't matter. I think I mentioned earlier, you're going to need to unscrew all of these terminal jacks most likely, and do it all the way. If you just unscrew them halfway, you can kind of jam a wire in and tighten it up, but it never really locks down. So, once you'll think it's all attached, and then you'll move the cable gently and it'll just slide loose. So once it's in there, give it a little tug, make sure it's perfect. This goes for all of the terminals that we're going to be wiring up. And there you go. That's the heating element. Next, we can do the thermistor from the hot end. That tells the computer exactly what temperature the hot end is running. And again, it might be smart to label all these things before you bundle them together, just with a piece of masking tape or something. The thermistor from the hot end goes right here into this jack called TH1. Like so. This is polarized. I don't think it matters, but the wires, I'm just going to do it anyway. That's about it for the electronics I have. I have yet to install an extruder, so when I do, the extruder motors will get mounted here. If it's a single motor, you'll use E0. Dual extruder will use the E1. Check out our other videos and the wiki pages and Blue Eagle forums for information on hooking that stuff up. The hotbed the thermistor is going to go over here, and the heater element gets wired into the AC power supply through the SSR relay, and that controls the on and off. We're going to get to that next. All right, next we're going to mount the fans and electronics to the effector plate. For that, we're going to need the 3 small fans, the wiring harness, the M3x8 hot end to effector screws, the M3x12 fans to effector screw, and our assembled hot end. We're using the E3D light. Yours should come assembled, but if it doesn't, you can check out the E3D wiki page for assembly instructions. Or if you want to put on a different extruder or the dual extruder, check out our other videos. I'm going to start off by putting this guy in first, and it's probably going to be easiest to fish it up through. You can take off the effector plate. That might make things way easier to work. Like so. Remember, you want to be really careful with these delicate wires, especially the ones for the heater element. So try to bend them as little as possible. Like so. Going to use 3 of the 3x8 hot end to effector screws to lock the top of the hot end into the smaller hole. All the wires will run through the larger end. Next, I'm going to mount this and do the fans in place. That'll just be easier for me, but you could screw the fans on the bench. Next, I'm going to take the 3 small fans and mount them onto the effector plate like this. Take note of the direction on which your fans will blow. On my case, it's with the label inward. We want the air to be going this way. It may be different on yours. And I'm going to mount them so the wires are coming out of the top. They simply get screwed into the threaded holes on the bent portion of the effector plate. Like so. For this next step, we'll be needing a soldering iron and some heat shrink. Now that the fans are mounted to the effector plate, I'm going to take all of the red wires and all of the black wires from the 3 effector fans and connect them together so the fans are powered in parallel. Note that the fan on the hot end is separate. It's on its own cable and power line. Like so. And we can join this to the rest of the wiring harness for the hot end with zip ties. Like so. All right, now that we have the effector plate all wired, the motors, and the front panel, it's time to prepare the build plate. I'm going to be using the Gecko Tech plate and the AC-powered bed heater. So I'm going to put this on the back. Before I get into putting on the adhesive-backed bed, I just want to align this up and figure out where I want the wires to go. I think for me it makes sense to have them oriented this way so it's near the relay to where they're going to be attached. So that would mean orienting them just slightly off of the tab here. So, and then I'm going to clean off the back of the Gecko Tech bed just to get any oil and grime off so I get a really good bond with the adhesive-backed heat bed. I'm using denatured alcohol or rubbing alcohol will work well. Yeah, make sure it's completely dry and then we can begin to attach the heat pad. So what I'm going to do is I'm going to start peeling it, but not remove the whole thing. I'm going to pull back a tab like this. And I want to make sure it's really aligned. So I'm going to fold back a tab like this, but then start aligning where the paper is still on. That way you can get it all smooth. You can get it all repositioned and it's like slippery and smooth. It's really important that you get this right. The adhesive's very strong, and this isn't something you want to, try to reposition after it's completely stuck. So when it's just grabbing by this folded down edge here, you can, align it perfectly, run your fingers around the edge to make sure you have the same amount of overlap. And when you get it just so, really push down the part where the adhesive is revealed, and that will anchor it. And then you can flip it up underneath and grab the paper. Be careful, don't bend this too much. There's a whole delicate circuit board in there. So kind of keep it as flat as possible. And you can just pull the paper out like this, just like so. And then, carefully and deliberately kind of work your way around and get out any air bubbles or pockets, and make sure it's fully attached all over. There. Great. Next, I'm going to prepare these wires for mounting to the board. The two heavy gauge ones are for the heater. I'm simply going to strip a little bit of the insulation away and solder them together to, these are going to be attached to one of the screw terminal blocks. So I'm just twisting the exposed wires together and tinning it with solder. This kind of glues all those strands together, and it makes it stronger and easier to fish in the terminal block eyelet. Like so. And these two skinny red wires are for the heat bed thermistor. These are really delicate, so be careful with them. These attach to the connector terminals over here, so they're going to need a female jumper attached to it. So I'm going to take a short one, and I'm going to also use some heat shrink here, so I'm going to cut two little pieces. With the thermistor, there's no polarity, so it doesn't matter which color you wire to which. Twirl up some of this extra cable and maybe throw a zip tie on it just to keep it together. Now, our heated bed is prepared and almost ready to mount. Next, I'm going to wire up the solid state relay and the AC power supply and the bed. So as I may have already mentioned, the heated bed is AC powered. So it takes 110 volts from the wall, and it goes through the relay, then to the board. And on the other side of the relay, there are two DC controlled terminals which allow the control board to turn the heated bed on and off. So the way we wire this up is by hacking into our AC cable that comes with the power supply. I'm going to plug this in to figure out how much cable I should leave, maybe about there, and just cut this AC cable right in half. I can remove this, cut that right in half. I'm going to strip back the insulation, the outer insulation on these two AC cords, And it looks to be inside. The two colored wires are blue and brown. You may find white and red or white and black. It doesn't necessarily matter. AC, especially in this case, the power plug on my DC converter flips both ways. So it doesn't, the orientation's not going to matter so much. So the way this will work is, I'm going to reattach these actually, because we want power to come in through the AC line and go to our DC converter, but we want another line to run out into the relay. So this will allow us to tie it all together. Here, I'll show you how it's going to work on the bench, more or less. One line from the heating bed is going to be permanently tied, and you can solder these together. The other line will have a wire that goes to the relay, with another wire returning to the other leg of the heating element, like this. If that makes sense. It's probably more clear if you just look at the wiring diagram. Okay, I got the AC power / DC converter / hotbed wiring all completed. I'm going to leave this disconnected for the time being and wire up the DC side of the relay to the control board. This has a plus and minus terminal, so be mindful of the polarity. And this is the control side. The control board sends signals to this relay that turns the 120 volt AC side heating element on and off, basically. So we'll have two wires that attach to these terminals and run back to this tall heater screw terminal jack right here, like so. So I'm going to prepare these wires by tinning them and cutting them to length. And there we go. The DC portion of the relay is connected. And I'm going to take my hotbed AC wiring harness. And the way this is going to go, again, is basically splitting the AC cable and putting it back together, but with one of the heating elements attached to one side and an extra wire coming out of the other side. The extra wire and the remaining unsoldered heat bed element are going to be run through the relay like this. which allows the main board to turn off and on the relay and the hotbed depending on the program. I'm going to hold off on wiring this up right now, just because there's a bit more I need to do down here. Install the firmware onto the SD card and check all the motors and switches to make sure everything's connected properly. The heating bed is sort of the last thing, and once it's on there, it makes accessing the control board a little difficult. So we'll get to that later. Hey, welcome back. In this video, we're going to be assembling the extruder for the Blue Eagle Labs all metal Delta. To start off, we're going to need a drill bit, a tiny drill bit, an X-Acto knife or some other cutting tool, and a PTFE tube that comes with your hot end. We'll also need the extruder plate, the one half of it with the L-shaped piece. So I'm going to start off, I'm going to cut about 4 or 5 inches of the PTFE tube. This is going to be the input feed, and then this is going to be the output feed that runs to the hot end, as you can see on this one. These two ends are going to need to be threaded, screwed into these little threaded holes on the bracket. So the first thing we're going to do is put threads on these, and we're going to use the M4 nut that comes supplied. We'll just use one of them. And what you need to do is chuck it into the drill. It's maybe a little easier said than done. Get the nut chucked into the drill, and then cut a slight angle onto the tube to help thread it into the nut. And what you're going to do is stick the tube in the drill right into the center of that nut and hold it as firmly as possible, and then slowly spin the drill. What you want is for it to catch and start winding basically like this. So I'm going to reset the nut into the drill further out at the tip, and I'm going to go again. So hopefully the drill bit will grab the tube and it'll start threading up. You don't need to go too far. About 1/2 inch is plenty, maybe 3/4. And then what I think is a good idea is to back it out and then go forward again. Do that 2 or 3 times. That really clears out the tube for you and makes it, chews away all the extra debris. So I'm going to repeat this process to the other tube, so I have 2 ends that are threaded. Like so. And we can leave the nut on there, tighten it up all the way. You can use this with or without the nuts, but basically we'll once we thread this into the hole, we'll cap another nut on, and that's sort of a reinforcement in case the plastic ever tears and slips out. So now the holes in the extruder plate are threaded, so you're going to have to twist the tube in there. Now what I find handy is to coil up the tube like this. That gives you a little bit of a grip. Just be careful that you don't kink or crease the tube in any way. That's going to really kind of mess up your filament feed. But if you ran that nut over there 2 or 3 times, it should screw on really easily, like so. And I'm going to put another nut on this side. Maybe thread it out a little bit more. And then tighten up these nuts here. Again, I've seen builds with and without the nuts. I don't know if it's necessary, but it's a little bit of insurance. Like so. Now, I'm going to use a small drill bit to ream out the inside of the tube. Even though we threaded the tube, when we put it in there, it's still soft and compresses slightly, and so the inner diameter is a little more snug than we would like. And we want the filament to just flow and feed through there unimpeded. So I'm going to find a drill bit size that's very close to the 1.75 millimeter inner diameter. It can be a little bigger. And just carefully, just ream out that little center area. If you have a piece of filament that you can experiment with and try to feed in that hole, this would be a good time. Just make sure there's nothing that's binding it up in there or catching, and you want it to kind of just slide in and out nicely. So I'm going to do the same thing to the other side. I'll put the lock nut. I'll leave the lock nut off on the side. This is the input feed. This side's a little less critical. This is coming off the roll, and it's just lining up the filament to where the extruder motor and gear are. There's not going to be any force on this side, so I'm just going to leave it like so. So that's it. There's our tube is ready to go. Now that we have the input and output tubes mounted to the small bracket, we can assemble the rest of the extruder. I'm going to start with the idler screw. So for that, we're going to need a bearing, the M5 nut, the M5 by 14 pinch 625 idler screw, and the M5 washers. So the order that these go together, it's going to be the M5 screw, the pinch idler screw, an M5 washer, another M5 washer, the bearing, and then the nut. Another M5 washer, and then this will screw into the threaded slot, the threaded hole on the small bracket. It should line up right with our tube. Like so. You don't want to over tighten it too much because you can lock down the bearing, so make sure that the bearing is rolling freely. Yep, like that. That is the idler bearing. Next, we can mount the motor. It goes together something like this. So we're going to use 3 of the 6 millimeter, the M3 by 6 screws to mount the motor. So the way this goes together, so the motor gets attached with 3 short screws, and then there's a slightly longer screw that holds together this top plate. So we'll leave this one off until last. Like this. Now, to attach this top plate, we're going to need the M3x12 extruder pinch pivot screw. And I'm going to use a spare M3 washer to put in between here. So tighten this one all the way up. Again, make sure you don't over tighten things. It's very easy to strip out the threads on this stuff. So you can see there's a little bit of play in there. Maybe you want another washer, but it is supposed to wiggle like this. So we're almost there. Next, I'm going to put on the hobbed gear onto the motor shaft. And you'll need this small Allen key that's supplied. So I'm backing out the screw a bit, and then I'm going to slide it onto the motor shaft. We want this to all line up with the tube, the two tubes, and the bearing. It should be kind of like in perfect alignment. So I would adjust it by eye and then tighten it up, and then double check it. Actually, depending on the hob gear you have, you might be able to switch it like this, as long as the actual filament grabbing part is still in line with the bearing. Makes it slightly easier to tighten out at the end of the shaft like this. That's pretty good for now. I'm going to assemble the spring and the screw that holds it together. And lastly, I'm going to install the M3x45 screw through the remaining, pinch bracket mounts here. One of the springs, an M3 washer, and an M3 nut that on the end to cap it off. And you can just tighten this up until the spring starts to engage. We'll do final adjustments when we're testing the extruder to make sure it's biting the filament with enough grip to force it through the tube. But the assembled extruder should look like this, just like so. Double check that the hobbed gear is in alignment with tube and the two tube ends and the bearing, and I think we're good to go. I'm going to mount the extruder, my second extruder, on the back like so. You can really mount these anywhere. Generally, you'll want to keep them in the lower quarter of the height on the extrusions, and watch out that they don't interfere with any of the arms. We actually had ours on this way, and it seemed like it was giving enough clearance, but occasionally the fan and the fan would catch when it was printing at the very outside of the bed, so we had to reverse it. Seems pretty safe here. Unfortunately, if you didn't have the foresight to drop them in on the initial assembly of the frame, You're going to have to get some of these T-slot inserts into the inside track here, which isn't too difficult if you've forgotten. I'm simply going to loosen up these guys and drop 2 down in here, and then drop 2 new ones in from the top and just sort of bump everything down. If all the other sides are fully tightened, you can loosen these with not too much of a worry about things getting out of alignment. But I would still double check for square when you tighten everything back up. So drop down two nuts for the extruder. And to make this simple, to make this easy on myself, I'm going to rest the printer down on its side so I'm not fighting gravity the whole time. I'm going to push the top one down to the bottom hole of the L bracket. And add 2 new T-slot nuts for the top. Like so. Now, we're probably going to have to loosen up the eccentric spacer on the carriage because it's almost a little too snug for these to roll over the T-slots, the T-slot nuts. So I'm going to loosen that up so the carriage is a little floppy, and then I can slide them down and then tighten these guys back up so it's snug on the track. Now the last step is to simply mount the extruder to the T-slot nuts using the M5x8 extruder to extruded plate frame. And there we go. This is the X column motor, the Y column motor, the Z column motor, the extruder 1 motor, extruder 2 motor. These are your end stop switches. This is the X top end stop, the Y top end stop, and the Z top end stop. This is for the Z probe. This is the hot end thermistor. This is the hot bed thermistor. This is the triggerable fans. This is the hot end heating element. And this is the signal for the solid state relay for the hotbed, to power the hotbed. And then this is input, the power 12 volt. And also tied in with that is the power for this hot end fan that's always turned on.